This is the second video on naming ionic compounds. We're going to continue on, and now we're going to focus on the two types of negative ions we have. We have monatomic ions and polyatomic ions, and how to name a polyatomic ion. The example we're going to use is magnesium MgNO3 taken twice. And when you analyze this, magnesium is in family A, and NO3 is going to be a polyatomic ion. In order to name polyatomic ions, it's actually very straightforward. We are just going to pull up a polyatomic ion chart, and we're going to find our ion on the chart. So NO3 right here, it has the name nitrate. We're not going to try to name the nitrogen and oxygen individually. We just write the name of the group. So it's very straightforward. So MgNO3 taken twice. Mg's family A. We're not going to state the charge with Roman numerals. We're just going to write the name, magnesium, and then we just write the name of the polyatomic ion. Note that we don't say that there's two of the nitrate anions in here, because we can predict the formula of this compound via the ion charges, and this is the only possibility that exists. Take a look at this polyatomic ion chart in terms of the name, the pattern and the way these are names. Sometimes we have two ions, polyatomic ions between the same atom, so NO2 and NO3. Look at the difference between the names is in the suffix. ITE means we have less oxygens. ATE means we have more oxygens. Doesn't mean that we have 2 and 3. It just means less or more. So compare SO3 and SO4 as well. ITE means less. ATE means more ions. And notice the absolute number here is 3 and 4. These are different numbers than the nitrate and nitrate anion. So the ATE ion here had 3. Here the 3 oxygens was less the ITE ion. So again, it doesn't mean 3 or 4 or 2 or 3 oxygens. It just means more or less. We have phosphate as well, PO4. The PO3 minus 3 ion is not shown on this chart. That would be the phosphite ion. We're going to come back to the name of these ions in a different video as well, so that's why I pointed out here. This slide says the same thing I just said a sec ago. So, some easily confused names for naming ionic compounds are shown on this slide and the next. So we have 3 ionic compounds with magnesium as the positive ion and different negative ions. And these are the names of the 3 compounds, and we'll just have to match them up. And notice that the only thing different in these 3 names is shown in green, and that's the suffix. So to match these, remember our rules. When we name a monoatomic ion, we change the name of the what we do is we take the name of the element and get rid of the last suffix and replace it with IDE. So this monoatomic ion is going to have this name, IDE. In order to name these last 2 ones, remember the ITE suffix means we have less oxygens, and the ATE means we have more oxygens. So the ITE suffix goes with the one with less O's, and the ATE suffix means we have more oxygens. Here's a similar example. Here we have compounds between calcium and chlorine, and then some of the polyatomic ions with chlorine. These are also called oxyanions because it's a polyatomic ion with oxygen and another nonmetal. But the one that's a monoatomic ion, it's going to have the suffix IDE. If it's an oxyanion, the one with less oxygens is the ITE. and the one with more oxygens is the ATE suffix. Here's some more examples you can look at on your own. Again, make sure you know when we put Roman numerals in the name, only if it's a family B cation. And when we name these polyatomic ions, don't name the elements in parentheses. This is just a group. And then we pull up a table to know the name of the group. The last thing we're going to talk about naming is bases in this video. Bases are a type of ionic compound where the negative ion is OH. The rules for naming ionic compounds are going to be the same as that to name bases. And that's because bases are a subset of ionic compounds. So a base is going to have a positive ion. Usually it's a metal cation. And then it's going to have a polyatomic ion. And that polyatomic ion is always OH. And the name of OH is hydroxide. So we get that by pulling up the polyatomic ion table. So when we name a base, we do the same thing. We name our positive ion. And the second word is going to be hydroxide because the OH is the hydroxide ion. So to name a few compounds, NaOH, Na is sodium, OH is hydroxide, sodium hydroxide. AlOH taken 3 times is aluminum hydroxide. We don't say there's 3 OHs because we can predict the formula of the base. All right, let's name these compounds. Name CaOH taken twice. Ca is calcium, OH is hydroxide. Again, I didn't state that there was 2 of them because we can predict that from the formula. TiOH, when we look on the periodic table, titanium is a transition metal. So we're going to have to state the charge in the name. I forgot to emphasize when I talked about naming calcium hydroxide that Ca is in group 2. So it's a family A cation. So we don't state the charge in the name. We just state the name calcium. But because titanium's in family B, I do have to state the charge. So I pull up that polyatomic ion table and I see OH has a charge of -1. That has to be balanced by +1, and there's only 1 titanium. So the name of this is titanium 1 hydroxide.